Alright, we're starting. So have a DevFest. I had a very funny company by notes of the intervention. I got from my friend for this. I'm not going to try to say it. Anyway, let's start.
Sorry.
My name is Florent Biville.
You can't hear or hear.
Okay, I will try to speak louder like this. I hope I'm going to survive till the end. Alright. So my name is Florent Biville. I work for Yazılım, a small consultancy company based in Paris and Lyon, so France. And my ambition today is to give you an idea about what Brave databases are made for and why you should try new project. I will take the developer point of view here. I'm not going to talk so much about operational stuff like we saw, for instance, in the previous talk on MongoDB. So it's really going to take the point of view of the Java developer. Of course, the Java code you see here, you can apply more or less the same for other languages, so don't be afraid. And let's start with something up. I guess you all know that. So let's go back to algorithm 101. So selection sorting. It's very stupid, it's very easy. To maintain the invariants ahead of the array sorted, and I try to find the next one for etc. etc. And if you do a slight change here, a slight customization to this algorithm, you just change the data structure basically. Take a heap, and you got a much more efficient algorithm. That is not new, far from it. However, you can see an analogy with NoSQL kind of. Yeah, okay, but the same algorithm, another data structure with a better execution time. So that is not new, as I said. This is something we already know. And if you just do a tiny analogy with something we know, NoSQL. What is the lesson of NoSQL? We've been used to relational databases since the 70s, and we never really, we just got with the idea to put relational databases everywhere, and we paid prices, and we know it's kind of work all the time. So for one data structure, one usage, we can also apply the same idea to NoSQL, maybe one data store or one database, one usage. And that's what Martin Fowler coined when he talked about polyglot persistence. Because we know we cannot have consistency, availability, and partial tolerance, so we have to relax one of these three constraints. So depending on the business logic of our apps, maybe we can have some modules. For each module, we can use a database, so we can use MongoDB for a catalog, because it makes sense, we don't need any schema. Each product can have its own feature. We don't care, there is no schema, we can do what we want. We can use Redis for cache, use key value store, very straightforward, very efficient. We could imagine lots of things. Recommendation for Neo4j, we just do some graph traversals, have some business rules. And we can imagine lots of scenarios here. So that's really one of the big lessons, in my opinion, of NoSQL. You don't have to always use a relational database. Of course, the Excel is their domain, but there are other domains where you should strive at least for trying something else. So I don't know who's been in the MongoDB talk previously. Alright, so you saw more or less the same picture. But he forgot graph databases, that was not nice. But more seriously, key value stores, it's very efficient. Of course, its complexity is very basic, it's just key and value. But very efficient, it can scale very easily. Sorry if it's not relevant. Then we have big table like data stores, column-oriented data stores, like SQL, table. They can handle more, of course. We are above, of course, key value, but it's a bit harder to scale. Then we have document databases like Mongo, like Couchbase, and we have graph databases. So of course you will tell me, okay, very nice for very complex use cases, but it doesn't scale. Well, what does this slide show? Actually, 90% of the use cases are here. We are not all Facebook, we are not Google. We don't have to scale that much. And anyway, graph databases can scale, just the sharding part is a bit harder. So graph databases, one important term here, of course, is graph. So very simply, what is the graph? A set of nodes, a set of relationships between the nodes. That's it. Depending on what you're reading, depending on the literature, the graph database, because there are many, you won't find the same names, vertices for nodes or edges, arcs, etc. I would just talk about nodes and relationships. That's Neo4j vocabulary here, so I'm going to use that at the end of this talk. So yeah, this is just a graph, a simple graph. Of course, with the previous graph, we didn't store much, just ideas. That's not very interesting. So one of the common models that has emerged is called property graph. So not only you have nodes and relationships like before, but first thing, you can add a label on your relationship so we know what it is about. So if I take the graph here, I have someone named Marco that knows someone of Dallas, I guess. They have an age. They also know someone else. Marco created, language Java, something like that. So not only you have ideas as we have had previously, but also you have properties, and that's the big important part here. So every node can have its own set of property like here, and every relationship as well. And an interesting thing here is, if I take these two nodes here, they both have a name property. But however, this is schemaless or it is schema optional. So you have an age here and language here. Actually, every node can have its own set of property. So there is no predefined schema. And since Neo4j 2.0, so Neo4j is still in milestone version for 2.0, they brought lots of changes, and they actually brought what they call label, so nothing to do with labels and relationships. It allows you to bring a kind of flavor of schema. Because as I told you, every node can have its own set of properties, and every relationship can have its own set of properties. With labels, it's a kind of semantic grouping. You can say, I don't know, animal, and you can have several nodes with this label. You can have specialized label like dog, cats, etc., etc. So that's very new in Neo4j 2.0. That will allow you to do some tiny schema like this. Of course, there is not only Neo4j. That's going to be my main focus here. You guessed it. Today, but you have. So what I do, property graph, was introduced by Blueprints. The actual whole stack is called Tinkerpop. They define this interface as a property graph with Blueprints. They have their own graphs. They also support many other graphs. You have FlopDB, for instance. This is a specializing graph of Twitter. So it's about retweets, mentions, etc., etc. So it's a specializing graph. You have Titan or OrionDB, which are two direct concurrent to Neo4j, and you have even more. I won't even talk about RDF here, which is a W3C standard. It's another model of graph, which is 3+4, etc. But I don't have too much into details. But yes, if you are here, the question is, why did I bother about graph database? Why do we need that? First, your life bar knows it, because it's a graph. I know it's actually, what's so interesting about graphs, first, you don't have to train your business partners into UML. You just start to draw something and they will understand. They can even take part in meetings. Yeah, okay, you have this here relationship and other nodes. But maybe you should also introduce this relationship, etc., etc. I mean, you don't need to have a Bachelor of Science in programming to be able to draw that. That's very accessible and very easy. That's one of the first assets of graph databases. It's very accessible. Then the querying. The querying is very nice. It allows you to produce very, very complex queries otherwise in a very concise and simple way. And you can extract lots of information, not only from the data itself, but from the links you have to pieces of data. So yes, I like to call that whiteboard friendliness in new technology, because you just take a whiteboard, start to draw a model, discuss, refine the model, etc., etc. Everyone can take part. Both explicit querying here, I took two important examples, like Google Prego. Well, I'm not an expert on this, some are experts. What is their idea is somehow to have a graph querying layer on top of relational models, or at least other data stores. Why? Because they actually found that querying data, thinking in graph, is very, very helpful and expressive and concise. That's just another proof. If the items like Google and Facebook, things like that, probably some truth to it. Moreover, as you will see with some use cases, just after that, you can answer many, many problems thinking with graphs and using graph data stores. And one key part of all the use cases I will list just after is the data itself is not as important as the link, maybe the hidden links between your pieces of data. That's also very valuable. So for instance, very classic example, recommendations, people I may know. So my contacts know some people, maybe I know them, so maybe I should be suggesting this contact. Products I should buy, the same. I like Twilight, I like Justin Bieber. It happens that 3,000 other people also bought Ultimate Yoga. Actually, that's an example. You just compare patterns and you see, oh, okay, those guys bought those two books, but those who bought this one. And see, oh, it's you will be probably interested. And you can imagine much more scenario. Which movie should I watch, with whom, where, etc., etc. So recommendation is one field where graph databases can excel. Pattern detection, let's say you're an e-commerce website, you sell video games, and you are of course very concerned with frauds. Because when your game keys are blacklisted, you cannot reuse them, so it's a big waste of money. So let's say there is this fictional country called Fraudistan. I don't know, they actually almost never buy any games, like 5 games every week. And all of a sudden, I don't know, GTA 5 is out, and they all buy like, I don't know, 1,000 purchases per minute, and you're okay, oh man, what the fuck is going on? How do they do that? Just compare patterns. They have an history, they know how the shape of the graph is, and then all of a sudden the graph totally change. So there should be an alert, okay, there should be a problem with Fraudistan, we should check exactly what's going on. That's really pattern matching. You know a pattern, you're trying to see if it resembles. Disease detection is another example. I'm not a pro here, so I'm not going to tell you too much. Trend detection as well, that's actually a real project. You just analyze social networks like Twitter, and you realize that many people, let's say it's shown here, Guatemala tweeted about flu in the last 24 hours. So that might be a sign of epidemic. That's just an idea. Again, just by comparing patterns. Pathfinding is maybe the most classical example. So to find a path between two parts. So let's say family tree is a graph, so obviously one database will work. Got also kind of question, is X related to Y? So François Mitterrand related to Elizabeth II, which is answered yes, but that's not extremely unfortunate about that, but we could have done it. It was just 5 generations about, and then we could find a path actually. So there is a path, they are related, they are of the same family. Navigation, of course. So I'm in one place, my friends at another place, I want to go to the sushi place, the most convenient place between our 2 locations, for this price constraints and for this kind of, etc. You can imagine mixing lots of constraints and trying to find the most convenient way. Impact, actually another real project here for a French operator, telecom operator. They have some, they have to actually provide service all the time. They have some contracts. If the service is interrupted, they have to pay penalty to customers. So they want to know, I mean, on the whole French territory, if there is one network switch that fails, who will be impacted? Who is behind? Which customers are behind the network components? That's just graph actually. If I, okay, who is related to this number? It's even the same pathfinding that was also down exactly the same problem. And I could talk about even more use cases. I don't know if you know, how many of you are Java developers? Okay, not so many. But dependency managers, I guess you can have that dependency in Node.js and all that sort of stuff. But you could imagine using a graph to actually resolve dependencies of your project. Okay, I depend on this library depends on another library, etc. You can imagine a whole graph of dependencies. There is a very known algorithm called topological ordering that will give you the order of dependencies, how to resolve them. Community detection is another example, how to find by behavior. Just community of likings and taste, etc., etc. But again, that's just a very short list, there could be much more. About real projects, so there is an initiative called Open Tree of Life. Their idea is to list all proteins, I guess, to build a whole graph quickly Oh, actually, it's live for this, so you've got 3 of 5, I guess it's to list all spaces in the on here. And they use Neo4j for that. Reg4j is a solution. It's just built upon Neo4j to have a recommendation engine. Structure is very nice, it's a CMS built on a graph. So you just use a graph to link the documents, etc. And one very, very nice contest actually is a Neo4j new technology. We opened this contest in September, now that's ended. So people had to share, so in GitHub there is a concept of gist. You just share a snippet of code and you share it, people can comment, maybe submit changes. Here's the idea is kind of the same. Graph Git, what is that? You have a small picture of your graph and some relevant queries on your graph. So the contest was who has the most beautiful graph, let's say, or the most clever use of the graph. I really invite you to check this link. You will find many, many different domains that's actually crazy. I couldn't even imagine some issues were totally crazy, and yeah, actually, it totally makes sense. Like for Jira, for instance, hey, Jira, Christian Jira was using Neo4j, how to use the graph, it's actually very simple. But again, that's one example among many, many others. So yeah, in short, graphs are everywhere. Maybe you don't even notice it, but really, the graph is very ubiquitous. That's why have a look at Neo4j and I'm gonna try to motivate you to do that. So how did it start? Well, as every startup, you have some guys in the garage, coding days and nights in Sweden. That's the original career. They started end of 90s, beginning of 2K. And they were discussing because they had to replace Informix. Informix was not very interesting anyway. And they were really pushing Informix to the limits. Okay, we have too many workflows, too many documents. And so many connections. So we're working on that, connections. Oh my god, it's a graph again. And so they were starting by working on replacement of Informix, and then ended up with new technology, which is now promoting their main product. There are more or less 50 employees all over the world, all those countries. And Neo4j is currently milestone. So the 2.0, I'm going to focus on 2.0 only because there were many changes for long-term changes, so I'm going to focus on that now. They have several licenses depending on your business. They can support many nodes and relationships, for instance. So you still have time before you reach the limit. And even if you reach the limit, you can negotiate to high the limit even more. So that's in fact that's featured on the So now let's dive a little more into the product. So layers like classical. There's a physical layer here. You will be very interested from the core API. What can I do? What are the atomic operations? How can I query data? And then I will talk very little about these parts. Because if you don't use Java, if you're outside JVM, you can use REST API clients, and you can use almost the same way as I'm going to show right now. But let's have a very quick overview of what makes a database a graph database. Well, how does it work on the disk? Well, kinda, it's just a very quick overview. You don't have to retain any of this, just to give you a rough idea of what it's initial. So we have a simple graph here. We have 4 people, they know each other, always nice. But then how do I store the properties? So actually, properties, they are a linked list. Every node points to its first property, then the first property will link to the second, etc., etc. To have a specific file for properties like that. That's just the beginning of the story, because the hardest part is, the relationships. That's the most crucial part where you're going to traverse that. And that gets a little more complicated. Every relationship is part of 2 doubly linked lists. So every relationship, so if I take this one for instance, they point to the previous relationship of the starting node, to the next relationship of the starting node, and same with the next node. So for instance, if I read this, I have one relationship. This is the first relationship of this node, so there is no previous for the start node. But there is the next one, and I will show you after that. That will point here, etc., etc. Same here, the first relationship to the next node. There is no previous, and so it will point to the next, and at the end it will become a constant mess. If you don't understand this, yeah.
In switch example, failing is node or relation.
Sorry?
In say, switch example, previously you show. No, in the previous pages, there was a switch example. Failing switches.
Right.
Are switches nodes or relations?
In this case, it would be a node. So you traverse, you start from the node, the switch node, and it follows the relationship of the nodes till you arrive to customers. Then you know these customers will be impacted.
Yeah, failing is a relation.
Well, not failing, just the network as it is. You have a switch linked to another switch, linked to another switch, linked to many customers. Just by traversing that, you know that you don't need to model failures, actually. You know that if you try, from this node is indirectly linked to customers. So you already have the answer. If it fails, you just have to follow the graph here, you know all these customers will be impacted. Because the links are already there. You don't need to model, okay, if I cut this relationship, what happens? That's not the case. I already have my network as a graph. I just have to follow relationships. And I know who is impacted by which component failure. So going back to this beautiful picture, well, I don't blame you if you're confused here. Just remember that by having this clever structure here, that's how you can get very efficient graph traversals. Because if you want to jump from one relationship to another, it's very easy. From one node to another, you just have to follow that. You don't have to remember this, but just to give you an idea of why database can be made as a graph database. Let's start with more serious business. So now we've kind of seen that caches, I won't even talk about it, it's least recently used policy, and you have two levels of caches. Don't so much about it. Let's see now what we can do with araya. So basically you can delete, CRUD, nodes and relationships. So here is an example in Java. It's kind of the same in the language. So you have to wrap everything in a transaction. Then I have got my service, graph service, and I can create a node with a label and maybe set many properties. That's a very simple example here of creation. Is that readable for everyone, or should I spell every line? No, it's fine? Alright. One cool thing is, like MongoDB, for instance, as far as I know, they ship the test libraries. So you don't have to write your own driver stuff or something like that. It's already in the official distribution. So that's quite cool because it's quite useful to have testers already like that. As I told you, since 2.0, Java 7, okay, you're not all Java developers, but it doesn't matter. Some syntax here, but since 2.0 transactions are always mandatory, you have to wrap everything in transaction. As I told you a little before, labels are just a way to group your nodes in families. You can set up as families of nodes. So for instance, here I'm going to label character for this node, and we'll have a colors name on the system. Now the reading part is the updates. So if you use the core API, again, you imagine you've got a service like before, you wrap everything in a transaction. You will call find not by label and properties, so as the name suggests, you give a label, and you check the values. For instance, if I check the previous node here, it has a property name and the value of everything. So if I'm trying to guess this combination, what I can do is to give again one of the label, so character, gives you property name and the exact value, and then I can iterate over the result. That's just one way to fetch data. One very important thing, whatever the language you're using, avoid at all costs find by ID. It's still very present in the documentation, but as I showed you, the graph on this is basically what is an ID. It's not an identifier, just an offset in a physical file, and they can be recycled. So at instant t, ID1 can be attributed to Homer Simpson. Instant t+1, because of recycling, it could be another node. So don't store technical IDs like that. It's just useful for local comparison, but not for external comparison. So just avoid it. Whenever you see it in the doc, just close your eyes and like it doesn't exist.
What usages do you use to run the codes? Eclipse or Eclipse? What you use?
Neoclips is a visual Neoclips is to just view graphs. It's not an IDE like Eclipse or IntelliJ. Personally, I use IntelliJ, I have no problem. You can use Eclipse, you can use Eclipse, it doesn't matter. You don't have any specific plugin needs. For viewing your graphs, yes, and you can use Neoclips as you said, or Gephi, or leak pictures. And for deletion, well, you just find your node in some ways and call delete in the transaction, of course, and that's it. So yeah, just one gotcha though. When you delete a node, you have to delete all its transactions before. So it's the same transaction or in previous transaction, but you cannot delete a node, it still has relationships. However, the properties will be removed. Relationship is kind of the same, except that the way to create a relationship is to start from a node. So imagine I have found the node owner, done it. What will I do? I will create a relationship from owner to the destination node is donut itself, and I can give a name. This is a labeled relationship as I showed before. So what does it mean? Owner loves eating donuts. So far, so good. And if I want, I can add properties to relationships. So for instance, he loves eating donuts a lot, basically. And every single transaction has before. So the only original part here is you first start from a node to create a relationship. And this, the name of relationship has nothing to do with the labels. It's been here before to all And maybe one confusing thing is, as you can see, I didn't specify the direction. Like Homer loves eating, it goes to donuts. Because direction matters at query time. It's when you query that you decide to follow one direction or another. So if you want, in your business model, you can have donuts that eat Homer Simpson. You have monster donuts. But yeah, really, direction matters at query time, not at definition. Delete is kind of the same. You find a relationship, you delete all in a transaction, and we're all good. And yeah, you need to know, so it's a transactional database, concurrent access is managed with logs. So both start and end node will be logged. You cannot do anything on them while you're deleting the relationship. So as you can see, Core API is very low level. I can play with one node, one relationship, but I cannot do much. Transaction are already required, and this is going to go. There were some subtleties in illicit, etc. Technical IDs, I'm repeating myself, don't use them unless for local comparison. Don't store them as an external reference. If you really need an external reference, you can use this extension. So from Stefan Arboster, he's an employee of Neo Technology. He's created this extension to automatically assign real IDs, not technical IDs like this. And I showed you Java code. The REST API offers the same capabilities, so you can reuse them with the REST client of your language. It might be PHP, Ruby, Python.js, even Workspace for example. Yeah, any language. But now the more interesting part is how do I query data? That's quite useful in a place. So we've gone one layer deeper. You have two ways actually to deal with that. You have an imperative way, you describe very precisely how you want to traverse your graph. However, of course, totally you are responsible for what you describe. So if your traversal is inefficient, you will have to deal with it and monitor it and try to improve it. Another approach is declarative. You just describe what you want, not how you want it, and it will take care of how to retrieve the data. So the imperative way is called traversal. You have a traversal framework with Neo4j. The other way is mainly with Cypher query language. I will talk about it soon. Or Gremlin, which is from the T-Purple stack, which is more Cypher query language is totally specific to Neo4j at the moment. Gremlin can work with any other, well, many graph native cores. Let's see traversal. So basically, we have two directions. You can traverse the depth first, so I will go from the end of the branch and come back and go to the end of the other branch, etc. Or right first. You will go, like all the generation, if you think of a family tree, all the generations, all the next generation, all the next generation. So that's just two ways. And that is only one parameter of the traversal framework. This is only this parameter. What you have to work here is to provide a traversal description that encapsulates all these parameters. Then when you call traverse from a start node, it will actually execute and gathers all the data you want. You have many other parameters, I'm not going to detail the labels. But yeah, you can really fine-tune your query. It's quite powerful, but you still have lots of work to your responsibility. So if you need very specific results, go for traversals. So one example here, again, transactional. So you have a transactional block, commit, and then I describe, so I start out with traversal description. Then I have a Florent API to build what I want to retrieve. So I will basically emulate Git-log. So Git-log is a way to restore commits. It's very simplified version here, of course. So I will go depth first because I will want to go to one branch of my project. So in Git, just the end of the branch, depth first. I want to go until maximum, I don't know, 10 commits. And I will only check parent commit relationships. So I have commits, which are nodes, and parent commits, which is a link from one node to the other. So parent node, link. And from there I will go traverse from the head of my project node. And in the end I will gather all the nodes I have found and I will enter that. And that's basically simplified Git-log. You could do that with a graph. So that's lazy. Until you call traverse, nothing will happen. It will just store all your parameters in one traverse description object. You start the actual traversal by giving one start node, and then you can give a callback and just keep track of what you want. So that's quite powerful, but again, you can really blow up things. You can have very inefficient traversal because it's a graph that is going to be magically performing. To traverse all the nodes of the graph twice or 10 times or I don't know, of course it's going to take time. So it's a bit verbose to write. You can mistake. It's very powerful, but be careful. And anyway, we prefer ASCII or all of ASCII, right? That's why we love Cypher. So as you might have guessed, they love Matrix, the movie. That's why it's called Neo, actually. And Cypher, if everyone remembers the first part, is the train. But actually it's quite nice to one of Neo projects, Matrix. So we love ASCII art, but how can that be useful? So let's say, as I told you now, we're in the declarative mode. So I want to describe what I want, not how I want it. Let's say I'm interested in this partner. I have three nodes all connected to each other. A is connected to B and C, B is connected to C. This is what I want in the graph. Let's say I have this graph here. So how does it work? So it will find starting points, this one for instance, and it will compare, okay, how can I find this pattern? Oh, this matches, alright. These nodes go to those nodes and there is a link like that. Yeah, it works. I will do that. And so on. Same here. And in the end I will have gathered the results. That's basically pattern matching on graphs. So now let's see how can I describe the results I want. So the syntax, as I told you, is very ASCII-arty. Let's say you have two nodes, basically two rounds and an arrow. If you want to write that in Cypher query language, it's on the right part. So it's, if you close your eyes not too much, here you can see the resemblance here. If you need to name variables and reuse them into a query, you will give names like this. If you want to find all nodes that loads other nodes, you would write it like this. So I have a node A that loads node B, so there is a direction, so it doesn't work the other way. Sometimes I can describe the node. And if I take the previous pattern, you have several ways to write it. You can write it in one shot. So A is connected to C indeed, to B, and B is also connected to C, but sometimes it can give squarey like this, so it's quite incredible. You can split it with a comma. And you don't always do parentheses. So that is the match part. So this is a reading query. I can specify where I want to start, what I want to retrieve, maybe filter it, and then return it. That's a bit inspired by Sparkle and SQL at the same time, but yeah, the syntax is quite nice. And since Neo4j2.0 with labels, it will try to find itself starting nodes, so maybe you don't need to specify that. Let's find some examples. Can someone tell me what it does? Is everyone willing to do this? I just described you Cypher in 5 minutes. So that's someone else has the answer. Everyone is shy, I guess. Yep.
That means give me the human which identity is Homer and has a relationship to food, which is donut, and the relation is loves eating. In which human's name is Homer Simpson and donut's brand is Petricius.
Yeah, exactly. So what does it do indeed? I will repeat what he said. It will fetch nodes of label human. So a human that was eating food. These are variable names of the end name. So name of one node is Homer Simpson. The brand of the other one is Fatalicious. So it will basically return me Homer Simpson because he loves eating Fatalicious donuts. And yeah, I mean, I didn't pay you. You answer by yourself. I really think it's very intuitive something. Another example, if we wanted to build a very simple recommendation engine, does someone want to try? Or I can decipher it myself. If you don't get this part, it's fine. You can try to guess. Yep.
Save it like give me my friends and friends of friends that are at most that 10, and when you meet a friend and then come back to me, you won't include me again. So that part me greater, not you cycle instead. So give me my connections and at most level 10.
Yep, exactly. So what does it do? It's recursive here. Find, so there is an output of label contact and me as name Florent Biville. And I want, so this part is actually very powerful. It allows me to go to level 2 to level 10 of contact. Try to write that with SQL. You get that and many jobs. But really that's very concise and easy with Cypher and graph in general. So indeed that will retrieve all suggestions, all contact suggestions for me. And of course, even it's bidirectional, it could include myself, but I know myself quite well, so I don't need to review it. So basically that will just give me contact suggestions. That's a very basic and stupid recommendation engine, but that's just a basic example.
Actually, it can include duplicates, right?
Yeah, it can include me several times. Even I wrote this anyway, it will happen. Yeah, indeed. It would come back to me every time. I would be in contact with myself so many times. So, one important rule of thumb that you will find in practice: in match, only describe results. Don't describe constraints, because you can do it. If you're interested in contacts, you can define that there must be a relationship, but you're not interested in the relationship itself. Describe it to where it has a relationship between those two nodes. In match, do your best to only include what you want to return. So what is in match should be in return, and there shouldn't be too much more. Which where, for instance, you can write this, where A has a relationship of type F with B, because you don't care about this relationship. You just want it to exist, but you're not going to return it. Or you can even negate the relationship, where A doesn't have the F relationship with B. Another thing which might be specific to Java, or maybe I'm not going to use that list. Favor parameters, not markup values in your queries, then the execution plan can be cached and can be reused. And I really suggest you to Google this article, it's very nice. It tells how everyone who tried Cypher queries and then he had performance issues and he explains how it improved them. So that's very interesting. The link was too long, so I just say Google that on this website. Very interesting. And since quite recently, Cypher was a very small type of project first in the new technology. Now it's grown to a feature language. You can write, so it's quite cool, it's quite useful. You can create, and very simply into O you can merge. We will see two examples. So let's, for the first time we see several labels. You know we can have several labels. So over, I want to create it with this label or symptom, like JSON style. We will have label human and that. Very simple. It can be much more complex queries. You could do something like this. So I didn't talk so much about it when I was done. After that anyway, but you can have Lucene is embedded in your 4J, so you can have indexing query, full text searches like this. I want all nodes from the index name characters whose names start with 1. So full text searches, that's quite cool. So I have the starting node, I want to match everything that is labeled junk and food. I want again the brand facilitation. And from that I will create a relationship. Because when I want to create a relationship with Cypher, I need two nodes of course, start nodes and end nodes. So I must continue them one way or another. So here are two examples of returning nodes in Cypher with two next queries, or with just a simple match where. And then I will return log, so owner log splitting again, junk food, infinite, just a joke, of course. And merge is very new to O, it's the milestone as I told you. It allows you to try to match, and if it doesn't match, do something else. So for instance, try to find Keanu Reeves. If it doesn't exist, then have a created date property. If it does exist, just update the last copy. That's quite nice, because everyone is saying, yeah, my database allows very evolutionary design. When you don't have schema, it's a bit hard to maintain, your model. So with this kind of stuff, if you wanted to, let's say you have MongoDB and you have cars, and all of a sudden you have to add one property to all your car model. You will have to change all documents to add this property, and that's very annoying. And that you can actually do that with merge. You can find, okay, if it doesn't exist yet, do something else, add this, etc. But that's very new. So Cypher will become very soon the way to go with querying data. Because I told you traversals are powerful, but you have lots to write. The syntax, in my opinion, is super nice. I don't know if you agree. But at least, people would answer my questions and don't try it. Merge can allow changes quite easily. And you don't even need to install your 4J. Just go on this URL, you can just play with some Cypher statement, import data if you want, try to stream queries, and then if you're convinced, I invite you to download it. But really, Cypher will become the one way to query data, I'm pretty sure of it. All expect to query language from a database, it's what we're doing. And now let's change topic, object graph mapping. Because the graph database is very dynamic, you have only nodes and relationships. Yeah?
Before changing the topic, can I ask something about Cypher?
Yeah.
Is it possible to write a query like, give me anyone that I can reach in at most 10 steps from contacts, but give me at most 3 items per every city, for example?
Well, you have, I guess you would group by a limit in this case, and we will be happy. So I guess
Is it support?
it is including the language. So group by a limit, we will probably do it. Sorry, I'm not in very good state to think too much, but the group by and limit would be nice. So object graph mapping, why? Why do we need that? We all know kind of object relational mapping works, 80% of the time. It's a big headache. Last 20%. Why? Because there is a very pompous term called impedance mismatch. Well, it just means that we have squares and rounds and it doesn't fit quite well. Well, object graph is not quite the case. But there is one thing. Graph is very dynamic. You don't have schema, but in your typical enterprise applications, you have a whole set of entities, you have your repositories, your service, your controllers, etc., etc. You have a very finite set of entities actually most of the time. You don't need a so schema-less model. So that's why object graph mapping can be useful. And before I talk about spread data, we just have a small footnote on Hibernate OGM. So I don't know if you guys know Hibernate, which is right now quite on par and to Java world. They wanted to push the idea to C++ stores, so that's how Hibernate OGM was created. It uses Hibernate Core, Hibernate Search, I guess. So it's usable for key value stores, document stores, and they have pushed 3 days ago, so it's very recent, a very early draft of Neo4j integration, which is very basic. And again, we reuse Hibernate Core, we know its limits, and that's maybe not the most clever choice to do right now. Anyway, let's talk about something nice. Spring Data Neo4j. So that's applicable only to Java, so I'm going to go fast and let's not go interest so many people. We have Rod Johnson, who is one of the founder creator of Spring. Now he's working with some Scala stuff, and Emitter Frame is a big boss of new technology. And in 2010 they met either Java 1 or Spring 1 conference, and they just fell in love with each other. Fell in love. Rod Johnson really simplified the enterprise world at the beginning of 2K with Spring, and he really wanted. He saw Neo4j. Oh man, it's very powerful, but it's very verbose. There is many things we could do together, and that's how you got Spring Data Neo4j. So Spring Data itself is an umbrella project. You have a very thin common layer. It's very important here because with ORMs we have a common model for all kinds of relational database, and you have only the subsets you can have with that. Here it's not the case. You don't care. You have a very thin common layer, and you can exploit any feature of the stores in different APIs. They don't try to make a uniform API because that doesn't make sense. When you use a document data stores, you don't expect the same API as for a graphic or a key value store. So they don't try to do that. They are very, very thin common layer and very diverse support for many using customers. So let's see an example. So sorry, it's Java. So if we tried to write a repository, so a data access object kind of, I know I'm not too late right here, but let's simplify. So here you would try, okay, you want to create a branch, so let's say you're writing it in graph. You would have a node parent and commit for some properties. You would try to get your graph database service, create a relationship between the parent and the commit, with an enhanced branch, set properties, etc., and you would have transactions. That's nice, but not so much. It's very, very noisy. I mean, you have to write lots of stuff. It's actually ugly, and you don't want that. So let's see how you can use Spring Data. That's it. Just have an interface and no code, and you have all basic operations on your graph. And what's very important, you can see here there is a branch. And what is branch? It's a business entity. It talks my business. It doesn't denote relationship. When I'm working with my clients, they absolutely don't give a damn if I'm using a graph database, a text file, or I don't know what. They don't care. They don't want to see that. Spring Data really allows you to talk about your entities, not about, like the previous examples, about node or relationship. That's just Neo4j. That's not unique. You shouldn't care too much about that. So let's talk, really with your model. Of course, you can have a bit more. And one good thing, you still don't write any implementation. It's still a contract. You don't write anything else. Because of course, there is some magic, let's say, you can find a way that works. just follow naming convention. So you say find by name like. It knows it's about branch. It knows about find, so reading. By name like, so you can guess to generate implementation for you to find branch by name. And it will return to you a collection. Of course, you cannot always rely on method names because it will become very long, find by name and blah 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 blah. So you can use add query. Just write some cipher here, and then it will generate implementations that executes the cipher statement and returns the results. And you can have pagination for free. And here is another long name, find by name, and commit identifier. So branch as commit, and commit as identifier, so it can guess for you. So that only applies to JVM, but that's very powerful. It can really generate implementation for you. That's code you don't have to write. And when you don't have to write code, you don't have bugs. And yeah, I won't detail too much about inheritance here, but graph repository, paging and sorting for pagination facilities, thread repository for creation, read, update, deletion, and repository, etc. It's not that important. You just have to follow a naming convention to get the implementation for you. And if you really need, you can implement yourself or use a query and you will be done. So 95% of the time you won't need to write any code. Just methods, method names, and that's it. And about entities. So yeah, I'm really sorry again for those who don't use Java, but you can more or less understand, I guess. It really looks like Hibernate or JPA. You have an entity here that represents a record in the data store, be relational or not. You have an identifier. You want to say that the name of person is indexed. You can use full text search, is what you see. Index name is that. You can fetch, you can hydrate your entities. Okay, this guy owns a car, so you can just annotate it, define for you. You can also get the relationships themselves or traversals, and you just have to write your annotation. It's very common in the relational world in Java with ORMs, and this brings the same familiarity here.
So, like the search engines, like the Facebook, the open graph, something like that.
No, actually, yeah, they don't use free data, they don't use Neo4j, they make their own, because they like to make their own anyway. But yeah, they had to. There is a very nice example from Max DeMarti, the employee of Neo Technology. He already implemented graph search with Neo4j and some not even nicer query language. So Max DeMarti is a thing to remember also. Relationships, it's kind of the same, so I won't go too much into it. You have a startup and the non-startup at the end, that's it. And you can have even more, so it shapes the axe for you. I mean, it gains you lots of time. You can Neo4j templates, so it will just hide lots of technical details of query data, so you will focus on the essentials. You can have geoparcels queries. One very nice feature, I don't have time to detail, is cross-store support. You can have one entity, you can say, okay, part of this entity is going to go through relational database, and the other part going to Neo4j. You can mix JPA annotations, for instance, and Neo4j annotations. So you can really mix, okay, this set of properties goes to Neo4j. Only of this set. And you have even more. So, there is so much to talk about, it's little time, so I won't dive into the details. Okay, you can done. You should check Cypher, it's really nice. Just try console.neo4j.org to play with it. You have Ninja bots that have fragments of things. You have Ninja Curious, which is a very nice database thing. It's online, so if you wanna see your graph in different ways, you should try it. GraphingDB is awesome, so you can have the graph database as a service on the cloud, so you should really try it. Heroku add-ons as well. And you have so much more. Again, I showed Java examples, but the REST API also exposes the same capabilities, so don't worry, you have the same new language. Also, one small library I'm writing right now, it's called Neo4j. So again, it's specific to Java, but it's for testing. It brings even more fluent test assertions. Neo4j is a fork of fast assert, I don't know if you know it, fast assert, Java library. But anyway, it allows you to have even more readable tests, because test is of course very important. And that's it. Do you have questions?